Converting machines turn corrugated sheets into boxes. These machines print designs and branding onto the boxes and cut the boxes into the proper dimensions for their need. There are two main types of machines: rotary die cutters and flexo folder gluers. The flexo machine glues and folds the box upon completion, while the rotary die cutter leaves the box unglued and flat. Rotary die cut boxes are typically formed by hand, such as pizza boxes, or wrapped around a product and joined on a customer's equipment. A rotary die cutter also has the ability to produce multiple boxes from each sheet, whereas a flexo machine yields one box for every sheet. Through a series of lasers and optical sensors called photo eyes and communication between an inventory management system and real-time production scheduling, material is transferred to each machine center onto an in-feed conveyor. Automatic transfer carts keep each machine fed with corrugated sheet stock. Each stack is broken down into smaller sections, called blocks, and shingled individually to a feed table. The sheets are fed via a set of feed wheels that work in conjunction with feed rolls that insert the sheet in the machine. Feed rolls are made of a soft durometer material that prevents the board from being crushed. Maintaining board caliper or thickness is essential to providing overall board strength to the final box. A vacuum transfer system carries the sheet through the machine across multiple print sections. On a rotary die cutter machine, the designs and branding are printed on the bottom of the corrugated sheet stock. After the stock moves through the print section, it reaches the rotary die cutters. There are different cutters for every box type that the factory produces. The cutters are built from two half cylinders with metal blades embedded, as well as foam rubber sections to eject the cutboard scrap pieces. Scrap is recaptured and recycled back to a paper mill to be used in future roll stock production. The next section is called the scrubber, which removes any remaining loose cutouts and any rough edges on the cut sheets. The sheets are then shingled again to slow down the speed in which they reach the stacker. If the cut sheets hit the stacker too hard, it will damage their edges. The stacker beds accumulate the sheets into stacks, which are then discharged on moving belts for the stacker operators to perform quality checks and prepare for strapping and shipment. The beginning of the flexo process is very similar to that of the rotary die cutter. Stock is fed into the conveyor by the automatic transfer carts. Each stack is broken down into blocks. In this flexo machine, the printing is done on the top of the sheet, so the stock must be inverted. The stock is transferred to a pre-feeder, where the stacks are inverted. This automation eliminates the need for manual inversion. The sheets are then shingled and loaded into a feed bed, where feed rolls insert the sheet in the machine. Print plates are mounted on a cylinder, and an ink system allows ink to be applied to the print plate, where it transfers the ink to the board as it passes through the machine. This machine uses rotary die cuts as well, but it only produces one box per sheet, unlike the rotary-only cutter, which can produce multiple boxes per sheet. The scrap is again recaptured and recycled for future roll stock. On a flexo machine, glue is applied in preparation for folding. After the glue is applied, boxes are carried through a folding section with vacuum-assisted belts and a series of folding rods, forcing the panels to fold in the proper sequence. The folded box is now glued and joined as it exits the machine and is stacked into bundles to the customer's specifications. Added compression time is given to allow the glue to fully cure. Depending on customer specifications, each bundle is strapped together to provide for stability in transit and ease in handling at the end user. To aid in the quality process, especially at high speed, a high-speed detection system called Clear Vision is used to monitor glue placement and gap measurements on every box. A high-speed camera is placed at the point of glue application and can detect the amount and thickness of the glue lines, as well as the measurement of the slots in the front and back of each box. These measurements are compared to a developed standard that can predict whether a bad box will be produced as it travels through the machine. Any out-of-spec box that is detected will be sprayed with a UV coating, and the bottom of the bundle will also be sprayed. As the bundle travels down the conveyor system, a black light detects the UV coating and will eject the bundle so that an operator can locate the off-quality box and remove it prior to reaching the customer. To account for the speed of production, a doubler is used to assist crew members in combining each bundle in preparation for load forming. The doubler stacks bundles on top of each other. These combined bundles are then assembled into a specific stacking pattern to meet customer needs. Load tags are inserted into each unit to uniquely identify each load as it is sent to shipping to be made ready for delivery to the customer.